Today's video is going to look at maximum and minimum values of a function. You might consider it an introduction to the topic, and it is for calculus, using calculus skills to find minimum and maximum values of a function. So I have three definitions here. You might want to take a couple minutes to copy those three down, pause the video, and then we'll continue on. Okay, hopefully you've paused it, copied those down, and I'll mention that these are not the formal definitions. You can go into a search engine, type in any of these words here, and you'll get a very formal definition. I just kind of put it in my own words just so we can talk about them. I do want to mention, though, that an open interval versus a closed interval. So in an open interval, it means we're not going to consider the endpoints of the function as part of the definition. Okay? So the open comes from open circles, and we don't include those. And then the closed interval mentions that we should count the endpoints. Again, closed circles mean they're part of the function. We're going to include that as part of this definition. All right. So I have a little graph here, and we're going to go through each of the three definitions just to get an idea of what each of them mean. So critical number here first. Critical number occurs when f prime of x, the slope, the derivative, is either 0 or non-existent. So as we run through here, let's first find the places where the slope is 0. So you might be tempted to say there, but that's non-continuous. So as we come down here, we see our first tangent line here. That's when x is 2. As we continue along, here's our next place where the slope is 0. Horizontal tangent line, that's at 4. And as I run through, no other horizontal tangent lines. So these two take care of the critical numbers where the slope is 0. Next, where the first derivative does not exist. So here is a discontinuous point. The derivative does not exist at discontinuities. So that's when x is 1. Here, even though it's continuous, that is a point of non-differentiability. We can't figure out the slope right there. Is it negative or is it positive? It's neither. We can't figure that out. So that's when 2, 4, x is 5. And right here we have another discontinuity. This being a jump discontinuity, and this being a removable discontinuity. And so that's at 6. So that takes care of our critical numbers. Notice, even though the endpoints, we might consider them derivative non-existent, that's true. But our definition says critical numbers occur on an open interval. So don't count these. All right, local mins and maxes. That just means it's the lowest point or the highest point when you compare it to the other points that are right around it. So as we go through, this right here is our first local minimum. I'm going to write local mins here. Right here, because as you look at just the points that are right around it, this is the smallest, it's the lowest. Everything else is a little bit above it. Okay, so we'd say there's a local min when x is 2. And if we wanted to go into a little more detail, we would say that has the coordinates 2, 2. Our next local minimum is right here. Even though it was a point of non-differentiability, when we look at it, it is the lowest point when you compare to all the other points around it. So here's another critical local minimum, and that would be when x is 5. And again, if we wanted to be a little more specific, we could say that occurs at the coordinates 5, 3. Let's talk about local maxes. So right here is our first local max. And again, as you can see, that is the highest point compared to all the other points that are real close to it. So that would occur at 2, 3, 4, 5. When x is 4, but at the coordinates 4, 5. There's another local max right here, because again, look at the points that are right around it. That is the highest point. Everything else is just a little bit lower. So that has the coordinates 6, 4. That occurs when x is 6 and has the coordinates 6, 4. So that takes care of our local maxes and local mins. And then lastly, our absolute minimum and maximum values. And notice here, this is it's a closed interval, so there's only going to be one local max and one local min. It's either going to occur at an endpoint or a critical point. So what's the absolutely highest point of this function? And I see that right here. So our absolute max would have the coordinates, well, I guess it's the same as our local max, 4, 5. 1, 2, 3, 4, 1, 2, 3, 4. And that is the single point that is the highest on the graph. And this one's a little tricky. Look for the lowest point, and you might say that, well, yeah, the function is definitely lowest right around here, but there is no local minimum value. Because we can't actually have the coordinates 1, 2, 3, 4, 5, 6, 7, 7, 1. It's never going to actually get down as low as 1. You might say, well, something just a little bit bigger than 1, like 1.2. Well, you give me a number, and I'll give you one that's a little bit smaller. We would never be able to talk about the smallest value.